Hi everybody, I'm Stavros Vassos. I'm going to talk to you a little bit about chatbots. We're going to go over four main themes, some introduction to chatbots. Some of these things probably many of you know, but we'll just go over that quickly. Then look into AI for chatbots and what's practically working on right now. Then move into UX and then dive a little bit lower level on a micro framework that can address some of the challenges that we'll see. Okay, right. So let's see. I'll just start with what is a chatbot, and this is the definition that comes up when you search for that in Google. It says it's a computer program designed to simulate conversation with human users. And what I really like is the note underneath that says it looks like often like a game of tennis, that talk, reply, which is kind of a reactive way of getting this to work. Another way to look at it is that the same way you talk to friends, you can now talk to applications. Let me just put my timer here. Okay, great. Now, when we talk about chatbots, there's a lot of things that we see around, and it's interesting to have a look on the spectrum of this. The ends on the far left and the far right, the extremes, are things that are very simple, like mobile apps that just happen to work inside a chat platform, and on the far right are things that are more sophisticated that we tend to think as AI assistants. So let's think about these two things very quickly. On the right hand side is the more happy versions of chatbots that we want to think. And the vision there is that these are actual entities that are smart. They can understand natural language, they can converse, they can think and find out what we want and even act on our behalf. That's a nice vision, and at the same time it's a difficult one, and we've seen that many times, also from the older times when Siri came up and a lot of jokes came up. This is one of my favorite ones that says, Siri, I'm bleeding, can you call me an ambulance? And Siri says, yes, I'm going to call you an ambulance. Like your name now is going to be the ambulance. Anyway, but we've seen it also through bigger projects that tried to actually make use of the most sophisticated things we have about AI and infrastructure and computing power. And this is one story not so much ago, like 1.5 years ago, by Microsoft that made a Twitter bot, a bot that was intended to work like a teenage girl tweeting about stuff on Twitter. And the point there was that the way it was communicating with people, it was updating the internal stuff and becoming, let's say, more intelligent or more adaptive to what was receiving, which unfortunately didn't work very well. Within less than 12 hours, they had to shut it down because this kind of adaptive thing made it actually say very, very bad things. And this is just evidence that it's difficult to deal with open-ended things and with language when you don't have a very specific context. On the other side, the simplest side, we have things that work inside a chat platform like Messenger or Viber, but they actually use the UI elements that are available in the platform to offer things that you would see in mobile applications as well. And in fact, the basic elements you need, like text box to get input and buttons, and then giving back feedback or information to the user are there. And here's an example of a bot that works inside Facebook Messenger as seen from the app in the mobile phone. And you can see that it's easy for the application, the bot, to send the same kind of interaction UI elements as a mobile app. So there's images in a carousel that people can see. There's buttons that look like links that you can click and go to other stuff. And there's buttons that can help you give responses and continue with the interaction. Okay, some examples just to see how these things work. And you can find them online. You can search on on Messenger and find out this on your application. So this is the chatbot by the brand Burberry, and it looks like an answering machine that you can click and select information and content and find out what they have to offer in the same way they would put it on a web page or on the Facebook page. This is the chatbot for the online travel service Kayak, that is for booking for flights and traveling. And this is a little bit more interesting. It has a little bit more of natural language. You can type things like, I want to fly next week. And instead of just clicking what is the next week, you can detect it. But more or less the same metaphor. Whatever you would get online or on the application, or the basic service of that, you get it through the bot as well. And one of the most, let's say, famous chatbots is one that just tells the weather. But I put it here because it's interesting that one of the most successful ones are the ones that are happy, and they give out this kind of experience that's through emojis and animated stuff, and have this happy, let's say, disposition. Okay, so we're mostly interested in what we can do in this middle ground between these two extremes, like the AI assistants we cannot get, and the mobile apps that, okay, they're convenient, but we can get a little bit more. And in fact, these examples are a little bit closer to the middle ground. Okay, so how do we build them? And what does AI have to do with building chatbots like that in this middle ground? And that takes us to the second part, which is about chatbot AI. In order to talk about chatbot AI, we have to do a little bit of chatbot anatomy. And we'll look inside how the actual system is connected and what happens inside the system of a chatbot. So first of all, whenever there's a chatbot, there's a platform that this operates. So that platform might be Facebook Messenger, so people actually have the application of Facebook Messenger, the mobile one perhaps, or the web-based one, and they work there, they talk to people there and the chatbot as well. So that platform acts as a mediator between the chatbot we want to develop and the people. The chatbot more or less works like a web application, like a backend of a web application that is receiving the messages that the platform receives. These messages go to the chatbot thinks, and then through an API talks to the platform again so that the platform delivers the message. What's more interesting is what happens inside this system, inside this loop of the chatbot. And there's some components that, even though you don't find them in all chatbots or in all ways that we develop chatbots, it's a good idea to abstract and think in terms of these three main components. And this is the natural language understanding component, the conversation manager component, and the natural language generation component. Okay, so more or less the idea is that the first component is the one that is going to receive the message from the user. It's going to analyze it, categorize it, take out any information that it can. Then the second component takes that information from the natural language understanding component, and along with other things that have to do with maybe how the conversation is going, what's the history of the user, and other features that are interesting to figure out what's the best way to respond, then gets a strategy for that response. And then the third component, which is the natural language generation component, is the one that's going to actually craft the response. So that might be perhaps a response that's different for a user if we want to be more emotional in that case, or something very dry, depending on the kind of chatbot that we have. Okay, so this view helps understand also the types of chatbots that we see, and we're just going to go very quickly on these two extremes that we said before on the spectrum, and see how they fit in if we see it through the lens of this abstraction. So first, the easy case of chatbots that look like mobile apps. They don't really have much thinking or AI, but how do they fit in this abstraction? So here's one that we did some time ago that it's more or less like a mobile app in the sense that there's a first screen, you see some things, and there's some buttons there, and it's supposed to give you information about the characters of this TV series Game of Thrones. So you see this screen, then you select, oh, maybe I want to find out about the Lannisters. I don't know if you follow Game of Thrones anyway. Then if you do that, you move to another screen. Okay, that screen says, okay, I have lots of Lannisters there. Here's one, pick one, and there, when you pick one, you see another one. But this happens in a kind of conversation, not as a screen, as different screens. Nonetheless, it does look a lot like developing a mobile app in a screen-based way. And in fact, that is resembled in how this would break down in these components that I was saying earlier. So essentially, the conversation manager keeps a state about where we are now, which options should I give you. The input that comes in, that might be even a written word or one of these buttons, detects the keyword, so we know which one you selected. And depending on the selection, the conversation manager decides what is the next screen, so to say, which comes as an outcome, as a response. Now, as you notice, there's no AI here. Okay, so we're just putting in this abstraction things that we would do to build an application anyway. Okay, now we go to the other extreme. The extreme of having AI assistants, which is the more happy direction that we're interested in. And in this case, all three components, more or less, are replaced by something more sophisticated, let's say. And for instance, we would have something that understands exactly what we say. That's the vision anyway. We take a sentence and then it's extracted what's its theme, what it's referring to, lots of other parameters. Then we have a conversation manager that's probably learning about you and what's best to move on to the next conversation. And even a natural language generation part that is crafting sentences that are best for this scenario. In fact, in AI research, this is one of the most difficult parts to do. As we've seen before, though, this kind of approach, and by the way, sometimes we think all of these three parts as a bigger system, especially now that we think in terms of deep networks and things that we kind of abstract the whole problem in series of examples, and then the features are more or less trained by themselves and by the data. And one observation here is that this doesn't work yet, at least. So there's no mature solution for handling all three of these aspects, either separately or together. And again, the interesting part is the middle ground. So I'm going to talk a little bit more about that middle ground. So what's happening now in most of chatbots you see, and also in the technologies that are around to support building chatbots, is that we focus all the AI smarts that we have only on the first part, the part of natural language understanding. And in fact, we're not even going to do what natural language processing research in general tries to do, which is I give you a sentence, parse it, break it down, find the semantics, connect it with other stuff, let me know what it means. We're not going to do that either. We're going to do something much simpler, because all we need is to be able to serve you some of the things that we have prepared with the chatbot. Maybe we need to serve you some data, we need to save some services. So we don't really need to understand what you say, we just need to map it to what we have. That's a far easier problem than understanding really natural language. So what happens is that a practical, let's say, natural language understanding component works this way. Oops. Okay, let me go back to here. Okay, so we decide beforehand that we want to detect a couple of themes. Let's say we want to understand whether we're talking about soccer, or we're talking about the weather, or we're talking about somebody asking for something. We can put these things, okay, that's not my pointer, that's why, but I'll manage. Okay, so we put these things in buckets, in examples. So you say, here's a bucket of examples about how you would ask for the weather if you were a user. Here's a bucket of examples about how would you ask about maybe the current standings in a soccer league or something. And then the system is able to find out for any new sentence that comes in, which bucket fits better. And that works extremely well because it's statistics, and because it can rely on work that we've done earlier. So these providers, let's say, of this kind of NLU components can work on the language that you are interested in, find out similarities between words and stuff. So when you put the examples and a new example comes in, it actually works very well to map it to one of these buckets. And there's another extra bucket that's called usually the default fallback, which is if it doesn't fit in any of these with good confidence, then we consider that it goes to the default bucket. Moreover, by this training that typically is done on the language beforehand, it is also possible in many of these services, many of these approaches that we can use for practical NLU to also extract parameters or entity detection, as it's typically called. So here's a screenshot from one other famous chatbot, which is for helping teams arrange meetings. And there, when you type things like arrange a meeting tomorrow or there, it's able to understand what tomorrow means, and sometimes even more sophisticated stuff, but mostly common things like date, numbers, colors. Okay. So these kind of services are provided by all the major tech companies. Facebook has with AI, Microsoft has Luis, Google has API.ai that now it's changed names, Amazon as well, and there's an open source solution that that's quite active too. And then just to go back to the abstraction and see what's happening, we have this part now that whenever some user says something, this goes to the NLU. The NLU maps it to one of these buckets. We get this bucket, this is typically called the intent, so understand the intent of the user. Then this goes to the conversation manager, and the natural language generation is typically authored stuff, so we don't really going to craft anything. We're just going to have ready answers and pick which is the one. And the conversation manager is just a system that takes the intent, figures out, okay, he wants to talk about soccer and this parameter, I craft the response. Okay, and how's that done? Well, there's no sophisticated AI, there's just code. So you can just do that. You can take the NLU, you can connect it to a bot, and whenever an intent comes, you say, okay, I'm going to serve it. I know how to code stuff. Okay, I craft my answer. Great. Just one note, that in general, this is all about the services you want to give, except for the fixed answers. So typically, this part of coding is the one that talks with either external services or internal services that have to do with databases or things that are specific on the business case. Okay, so then let's say that we have a view about how AI is handled, at least in the practical sense, not in the research sense, but in the sense that people build stuff like applications. How they do it, they take an NLU that's practical, they connect it somehow, and they code this way of business logic and they work. Okay, so what about UX then? How do we make this, you know, be pleasant and nice and successful and give a user journey that people would like? And this is actually very interesting. This is one of the first conferences that took place about chatbots, and that was the bag they were giving. And I think it's very accurate on what was happening in the very beginning when people were building chatbots. So it's like, what do we want? Chatbots. When do we want them? Sorry, I didn't get that. Because this is one of the most common reactions you get by chatbots. Like you type some things, it's detected. You type some other things, it says, I don't know. And a lot of these I don't knows actually hurt. Okay, so let's talk about chatbot UX. So we know what UX means in web and mobile apps, or I guess we do anyway. But what does UX mean for chatbots? And if you search online, you'll find tons actually of articles about UX for chatbots, like 15 guidelines, UX for chatbots, this and that. And most of these can be summarized to maybe a handful of rules that talk about authoring. Authoring the sense of keep your sentences small, use emojis. I don't know what I have here. Like put lots of intents about texture stuff. Like if they want to say, ha ha ha, put an intent about that. If they talk about the sea and the weather, put another one. So somehow you avoid this default answer, I don't understand. What was that? Anyway, but this is mostly on the authoring aspect of bots. And if we look at it in oops, I keep doing that. There, yes, right. Sorry for the dizziness. Okay, so and it's impossible to press that. It's impossible to press this without pressing that. Okay, so these things actually are, let's say, located in the part that has to do with taking the NLU and adding lots of examples, authoring stuff, and be careful of how you do the responses, authoring stuff again. But it's equally important to think about the UX in terms of the conversation flow. And it's much more important than, or let's say crucial, not important, than the mobile app that has a little bit of structure, because here you can just jump to any part of possibilities and conversations and points there. So you need to actually know how to control it so that people follow things that are meaningful, don't get lost. And this goes beyond authoring and requires developing stuff. So until now, you could even have a do-it-yourself solution and build a chatbot, but to control this, you need to be able to work around with managing the flow in code or in some tool anyway that is based for that. Just as examples, we're going to follow three simple, let's say, challenges related to the UX, so that we see how what they really mean and how we can address them. And even though they're very simple, they're indicative. And also when you maybe converse with a chatbot later, you can take a look and see that most probably not all three are, let's say, covered, satisfied by the chatbot that you're using. Because it's not so easy with existing tools to do that, even though they're very simple. So the first one says, don't give the same text response twice. So I say hi, it says hi. I say hi, it says hi. I says hi, it says hi. You see, that's bad UX, okay, it's clear. So it's on the authoring part again, but the underlying mechanism should support also that you have alternative answers. It's a very simple one. Still, many bots don't do that. The second one is, don't give the same options the second time that you ask for something. They don't have to work together, okay? This might apply in a different case. So this is something like, the second time you ask for this, don't give the same business logic. Maybe you say, okay, so maybe you were not satisfied by this, so maybe I give you a different answer. In any case, it's not an alternative answer as before, it's an alternative path this time. And the third one is similar to this. It's like, okay, you have tons of things you can ask for and tons of points or triggers that you can move on. How do you control this so that you give a guided storytelling or experience to the user? And this actually happens here. So we take this thing as a service perhaps, or as a mechanism that other people have made as a practical NLU. We author stuff, and here's what we need to do in order to make this work in better UX or in good UX. Okay, just to give you some idea, this is the CNN bot. Again, you can find it by going on Messenger and searching for CNS. This is the Burberry bot, and it used to be very bad when it went out. Now it's not that bad, it's just very simple. It's not that bad. But still, whatever you say, it says the same thing. Like this was yesterday. Hi there, blah, blah, blah. I say, hi there, blah, blah, blah. The same thing. Here, there's some question, you say, okay, it says, what is your question? I say, okay, what is your question? I mean, this is a brand. They probably paid a lot of money to do that, and it works like this. There are others that work better, but just following these three challenges is good enough to get you started about understanding which UX things need fixing. Okay, there's about the other two challenges. There's similar things that have been studied in other cases of having digital media, and in fact there's lots of resemblance with video games. And we'll follow the terminology of video games just to explore how we would think in terms of the storytelling aspect of moving around the possibilities of interaction points. And I did that wrong again. Okay, so I'll follow the metaphor of video games just to show how a flow of conversation might go. So there's a linear story which says that whatever I do, I can only move forward in one way. You can think of it in terms of conversations too. Whatever you say, it doesn't matter. The bot will say something else. There's a lot of bots like that, and interview sections work like that anyway. There's the open world storytelling, which is I choose every time what I want to do. It's more like a Q&A way of doing that. Like I ask this question, I get this answer. Okay, I ask this question, I get this answer. That's fine. And there are combinations of this, like islands of open world things that are linearly connected. So I can ask a few things there, or I can interact in this way. But when I move to themes, I get different options and different answers. I cannot move back unless I do it in a particular way. The examples are there from video games that follow that, because we follow the terminology and they work there, but the idea is just to see visually how the UX of storytelling would work. Okay, there's branching, of course, which means that after you take a choice about maybe asking something or requesting something or getting into a theme in a conversation, then you cannot go back until maybe the end of this session. And there are many combinations of this. And what happens is that typically not one of them is used like clear cut, because it doesn't work exactly right. And at every case, people do their own authoring systems. But when you don't do a kind of authoring system that lets you abstract these things, it's very often the case that by just writing code about how to deal with these things, like, oh, if then else, or maybe your own kind of data structures and stuff, you end up having difficulty in maintaining, extending, and using, anyway, this kind of approach. Now, when we go back to chatbot UX and the platforms there, and these are platforms that work, or tools, let's say, that work in this part, in the part of the conversation manager. What happens is that each one follows one paradigm, more or less. The most common paradigms are the open world one, like Q&A. This is mostly what Dialogflow follows. And a linear island way or procedural way that is more close to the mobile app screen-based way of structuring things. And what I wanted to show you next, for the next 5 minutes, and then Dimi will come up and show you a little bit more code, so that some of you that are coders are more happy to see that we do things that are practical as well, is to show you a framework for handling this part of code that needs to also do these UX things in a way that unifies most of the, let's say, mechanisms that the existing frameworks have, in a way that we can use all of them, put them in, put them down and design our story, our conversation. And this helps both to understand maybe the limitations of some of these platforms and how you can remedy them. And perhaps this can be also used as a starting point when and if you need to build your own framework for handling the management of the conversation and also UX at the same time. So, okay, I'll go a little bit quickly on that. We, let's say, put all of responses as nodes. So any possible response that the bot will give is a node. That node has a precondition that says which intent is the one that may trigger it. So we may have many nodes that could be triggered by the same intent. At the same time, in order to be able to be more refined, we have more things. We have a blackboard that keeps some labels. And in the node, we have some labels that need to be in the blackboard for this to fire. So it's like extra preconditions. Where do these preconditions come from? We need to have the intent that fired to be the right one, and we need to have some labels in our blackboard. Okay? And when this fires, we also have some post conditions that says, now I'm going to manipulate the blackboard. Maybe I remove something and I add something. So what this does is like a game. The nodes play a game by keeping marks on a scrapbook, on a blackboard, so that we can control and coordinate how nodes can be fired. And then the conversation manager can go over a very simple loop, actually. It can say, okay, let me see. Which intent fired? Let me know. NLU takes the intent, it gives it to the conversation manager. This one says, okay, there's only 5 of them that can fire, that have this intent. Excellent. Now let me check the blackboard. The blackboard says, this is on, okay. Which one fits best? Okay, I pick it up. I give the response. Technically, I give the response to the other component, but let's say I give the response directly, and then I update the blackboard so that maybe I mark that I just did this response or something similar. Okay, so I'll go quickly over a case like this. So let's say that it has to do with giving different business logic based on first or second attempt of the user asking for that. So the first time that a user says Voxxed, then you get a brief message. I love the conference. The second time that you get Voxxed, you get a different message that says, ah, okay, we've already said that. Yeah, but I like that. Okay? And you can have alternative answers here, but the point is that this is different response in terms of business logic. So how can you coordinate this? This is the simplest case you can encode. Both nodes, both responses need to be triggered by the intent that somebody asked about Vox. Okay, good. And the one of the two, which is the first one, doesn't have any precondition in the blackboard. We start with an empty blackboard, let's say, so this can apply. After you get this and you give this response, you go as a postcondition and add a marker. The marker I call Vx. Next time the conversation manager runs and it gets a Voxed intent, both of them are able to trigger, but this is more appropriate because it has the mark that is also on the blackboard. There's lots of room there to find out what's the best for you, and there are actually lots of AI background on how to do it, but more or less the mechanism is an action-driven mechanism that helps coordinate by keeping marks every time you pick a node, you do something, and you manipulate your nodes, so to say. More interesting is when you actually have contexts, in the sense that the second time that the user asks Vox, then you enter in kind of a smaller area. That smaller area of conversation says, I'm going to ask you, do you want to get updates? And I'm going to wait for an answer. If you say yes or no, I'm going to tell you, okay, great, thanks. If you say something else, I'm going to tell you, oops, can you actually let me know about updates, and then we can move on. How do you handle that? You can write code, you can write if-then-else statements, you can do anything you want, it's code. But if you structure it this way, perhaps it's a nicer way to abstract it. And in fact, this is how it looks. I'm not going to go into details, it's there, the slides will be online. But more or less what we do is we lay down all of our responses, and you see now that one of these responses will jump to another thing that asks for updates. And then there's the yes and no answers that somehow connect with this and the board. The details doesn't matter. It's a game we play between labels. And there's even a third Voxed response, which is after I ask once, after I ask twice, after I respond to yes or no, here's the response that I would get. Anyway, and with this, I'm going to pass it on to Dimi to let you know how this structure and this mechanism would actually work if you implemented this in a micro framework in Node, so that we get a little bit of understanding that how this works. This is not like a paper exercise, paper and pencil exercise. And this is actually also online on GitHub.
Test. Can you guys hear me? Cool, thank you. All right, we're not running too much late, so I think I have some time. Right. All right. So first of all, yeah, this is. I'm going to show you a little bit a micro framework we created, basically to illustrate all these concepts that Stavros has been talking about. This is not something you could use probably in production, but you can play with it. It's on GitHub. I'm going to share the URL. You can extend it. You're welcome to extend it if you want. But it's basically there so to show the basic components that are there if you want to implement a chatbot that really has a good UX. That's the one. So first of all, let me say why Node.js and why other languages. We've tried a lot of stuff. We've seen that with. You cannot hear me very well. Much better now. So with Node.js, we can serve lots of users in very small VMs. So that this is one of the reasons. Another reason is that you will find many examples online about how to get started with Node.js. What we see here is a block architecture, so it's a very high-level diagram of that micro framework you will find online. But it's very typical to what you will see if you start building, or if you have started building bots. This probably relates to you a little bit. So what you can see here is that you have I hope I'm pushing the right button. Yeah. So there's a platform. Through the platform, you're receiving in your backend a request with the message that the user sent. You have to process that inside your bot. What does that mean? You may retrieve that blackboard that Stavros explained a few minutes ago from the database for that particular user. So what is the state? Because you need some state. You need to process the input through the natural language unit. pass that on to the conversation manager, make some decisions, call external services, then create some message that must be sent. So this is the natural language generator. Well, it's not very sophisticated, this particular one. As Stavros said, it's very practical. It's a list of possible answers. And then you can forward that to the messenger, which is actually responsible of sending that back as a callback again to the platform. What we've found, what we've realized is that, this is just a description of what I just said. Just a small note here is that the messages may not all just be text messages, obviously. There may be images, sound, video, whatever. What we've realized is that if you start using Node through this 1+ years that we're building bots for companies, is that we've tried many different approaches to build bots, from borrowing concepts from game development, like behavioral trees, or procedural style. We find out that it's very difficult. Maybe it's because Node, I don't know, but we find it very difficult to have a very clean implementation and extensible implementation. So we try to find out, okay, what is the best way to structure those components that we've been talking about? And we find out, at least in our case, that the chain of responsibility fits very well. And I guess quite a few of you are familiar with the chain of responsibility design pattern. It's similar to Java servlet filters, for example. Or in Node.js, it's very similar to the middlewares. And what we realize is that all these components, what they do is they have some access to a common store. This is the Blackboard. They do stuff, they're self-contained. They do some stuff based on what it is in the Blackboard, and then they pass on the control to the next one. At some point, maybe one of these components, they want to block, of course, the execution because something happened and they don't need to send a response, for example. So all of these components, they pass on the control to the next. So we found out that this is a very elegant layout of those components when you're building custom stuff. I'm not sure if you can see this clearly. But what you can see is a very, in this framework, so I'm driving you through a few core components of the framework that you will find online. This is in Node.js, and this is pretty much the interface all of these components should have in order to fit into this micro framework. They have basically two functions. One is that is being called when the incoming request comes in, and they have a post-process, they have another chance to process the request when the flow comes back. So process request, post-process request. What you see in this one, in this slide, is basically how we synthesize those components in this micro framework. And because we follow this pattern, we just pretty much create a chain of those components. We wire them together. All of these components, they have something I didn't show in the previous slide. They have an add next method, so you can wire them together. And when when a request comes in, we pass that on to a process event function on the first entry in the chain, and that follows that path. So what happens? This is one of the components. Is, as I said, they all have. If you look here, they all have the same interface, and they take an input, the Blackboard. This is the Blackboard, as Stavros said, is a list of tags, for example, that represent the state where you are now in the dialogue. So this is pretty much the Blackboard. This is a very early stage of the execution. The user has said hi. The NLU gets this input. There are not contexts inside the Blackboard yet. We only have the event, and the user said hi. We process it through the NLU, and then the NLU says, okay, I'm not going to change much, but I'm going to add the intent ID. Now I know that the intent, the bucket that was triggered, was greeting. How are we doing with time? Not bad. Obviously, the next one in the chain, which after the NLU is the conversation manager, will need to pick that up, see, is there any intent that was triggered? Okay, this was the one that was triggered, so how do I handle this? I need to in this particular example, Stavros also discussed about nodes, action nodes. So we have many, many different nodes that the conversation manager can pick from. And how it picks the right node depends on the pretty much on what is in the context. What is the intent and what is in the context. Can you guys see this in the back, at the back? Yes? That's impressive. So you can see a very specific node here. What this node says is a small description, an ID. The intent name is Voxxed. This is what Stavros said a few minutes ago. And the input context, so what is the precondition to get this node triggered, is that the Voxxed has been discussed. So at least once we have discussed about this, about Voxxed. And what is the output context? It doesn't have any particular output context, but it says we must send this message. This is the message that must be sent, the txt Voxxed enjoying. That ID will be picked up later and in a later component, the natural language generator to produce the actual text. And to show you, I was hoping to show you a live demo, but I don't have internet here. This is a small example of, it actually runs, so if you get that microframework and connect it to your page, this will work. It says, I'm saying hi, the bot says something, dude. I'm saying, are you enjoying Voxxed? It says, I love being at Voxxed. So this is the second time I say I like Voxxed too. This is the second time I mentioned Voxxed. So the bot says, so you're enjoying Voxxed. Would you like me to send some updates about Voxxed? Thank you. And of course, you can use the same methodology to build way more sophisticated stuff. This is a very basic example to illustrate the concepts. So the framework is, you can find it out online if you want, play with it a little bit. And I'll be happy to hear your thoughts about the implementation. And with this, I'm going to hand over the control back to Stavros.
Okay. So just for the last 3 minutes, I think we have, or 4, 5, okay, good. I'm just going to summarize. I'm just going to very quickly go over some takeaways. The first one is that Chatbots is a new channel, okay? So even if you haven't been exposed to that too much, it can be seen as an additional channel that addresses, that lots of people like, mostly young users, called millennials. And one of the selling points is that you don't need to install an application to do it. Most people, for instance, have Messenger, so they can just talk to some bot and get similar kind of UI. And 2 other quick things is that, well, there's 2 ways to look at this. The chatbots are easy to build, so there's lots of do-it-yourself solutions for common use cases. There's developers working on that, and there's this similar craziness as was happening with mobile apps when they started. So there's traction, there's things there. But at the same time, chatbots are hard to build. That's because the expectations are very high. People expect science fiction things. And when we go back to more basic things like the ones we discussed now, even fundamental components like the conversation manager and the UX are not well defined. There are no mature tools for this. So you can see it both as an opportunity and as a weakness. So with that, I'll just leave the last 2 minutes that we have, maybe for 1 or 2 questions. And thanks for listening. You can find more information about us and the slides that are available on the last link. Thanks a lot.